This video is a part of series of videos describing the entire universe. I am starting from the early stages of the universe before the Big Bang. Discuss the various situations for the formation of the Big Bang singularity. Then the cause of the Big Bang at that particular moment is also explained. This video series discusses the subsequent Big Bang and the expansion, the structure of the universe and the end of the universe. I illustrate all this with the help of a new concept I have developed from my studies. In this video, we are discussing the Big Bang and its after effects. Rather than the other models of Big Bang, here I am taking space-time as an important factor. We are discussing the impacts that create in the space-time after the Big Bang. The influence of space-time to encourage the Big Bang is also an important factor here. At the very big moment, there are three important changes happening in the singularity and space-time. These three changes encourages the inflation era. The things that are happened in the Planck era are also discussed as the interaction between the space-time and singularity. As I feel, the Big Bang as a breakdown of the singularity and the space-time, it can never be an explosion. In every stage of the Big Bang, the reaction of space is also important. So when I am describing this, I am also explaining the reactions of space at each stage of the evolution of the universe. So we will discuss the Big Bang moment in this video. Let us try to understand that had the particles inside the singularity are in equilibrium and how they went through a Big Bang and so on. In the Big Bang singularity, the energy and the space were separated from each other and tried to create an equilibrium. Now you may ask that how the Big Bang happened in a universe that is so balanced with each other. One of the main causes is the imbalance between the ratio of space and energy. I think it is the main reason. And the other one is the gravitational force that is the fellow traveler of energy. I can find the answer to many key questions here that bothered me. In our visible universe, a star can be found if more than limited energy is concentrated in one place. Then why did the singularity so full of energy, the energy which can create the billions of stars and everything else that we see in the cosmos today, not undergo the Big Bang before? The primordial particles were so full of energy, there was no space left inside. We can understand that how much it was balanced. Similarly, we imagine a space can also say that it is perfectly balanced. The combination of these two created an unbalance in the primordial universe. It is because of the ratio in between them. When the primordial universe attempted to overcome this imbalance and with the help of gravity, the singularity has begun to form. As the singularity begins to form, the two particles merge together and become a single particle. What is the imbalance that caused the Big Bang in the singularity that is forming in the state of equilibrium? In any case, there is no space inside the singularity. Singularity is formed by expelling the space. As the singularity absorbs more energy, so does its gravity also increases. Maybe this has caused it to the tendency to shrink more. This may be increased its pressure too, and paradoxically, there was another activity. Increasing energy was proportionally curving the space-time around the singularity. Even though it was expelled out of the singularity, the space-time remained as part of it. For nothing can exist without space-time. We can really see many reasons which can break the equilibrium of the singularity. First, the pressure inside it, and then the curvature it creates in the space where it exists. Increasing curvature, singularity can also compress the space. In addition to this, as amount of energy within the singularity increases, the imbalance between energy and space increases. A normal black hole singularity may not bend the space in such a terrible state. But when we talk about the Big Bang singularity, we have to think about this because it had the energy to create the entire universe. It should have bent the space in a very terrible way than we thought. The reaction of the space against it, perhaps the underlying cause of the Big Bang. Maybe gravitationally curved space also needs the Big Bang to happen. As far as I understand, space is very flexible. Energy can use the space as it pleases. When energy expels all the space inside it and enters a singularity, the space around it is more likely to shrink. As the concentration of energy in an area increases, the characteristics of the space over there also undergoes some changes. The space around the Big Bang singularity must have been very much compressed. It was with such force that the energy within the singularity was pulled the space into it. The flexibility of the space also changes according to the pressure exerted by the energy on the space. The movement and the speed of the objects moving through it will change according to the flexibility of the space. We have proved experimentally that light bends under the influence of gravity. The space within the event horizon of a singularity must be very compressed. That's why even light cannot escape from there. This image is what I drew from my imagination in a way that everyone could understand. The red spherical part of the figure indicates the Big Bang singularity. The grey colored top side shows its event horizon, and the black curved lines present the terribly curved space-time. In a picture representing a singularity, we usually see a cone-shaped curved space-time. Things are a little more complicated here. The curved space-time merged together for some distance. After that, its curve slowly appears. I feel like a surface in the straight line was bowed down, folded, and as if trying to blend it in with each other. This is just a two-dimensional picture. In fact, spherical singularity creates a curvature of space-time from all its sides. When you try to fold the space-time with such a force, naturally there creates an imbalance. There is such a powerful activity there because of that much energy involved in this region. Anyway, by taking advantage of all these imbalances, the Big Bang happens. There is another point to consider. Does singularity occur only in one place in the universe? We can never be clear about this. We have not been able to understand the boundaries of our universe or its vastness. Let's just say that the universe is infinite. Therefore, similar singularities may have formed in many parts of the universe. Sometimes they do not store enough energy to happen a Big Bang. There was a Big Bang happened in a singularity elsewhere. It may have expanded and become closer to our universe. It may also share a space with our universe. Let us go ahead hoping that everything is good. We cannot tell how much energy in the whole universe had, but in the future we may calculate how much energy was in our universe where we live. Because our universe was formed from a singularity that stored at exactly a finite amount of energy. Now let us see what happened after the Big Bang. We have a clear understanding of that now. However, in my view, I would like to explain it more simply. We have been able to explain scientifically what happened after the Big Bang. With the Big Bang, our universe has to change its state into an expanding universe from its previous state of a singularity. When switching from one condition to another, the first thing it tries to do is to maintain stability. But we have three different scenarios here at the same time. First, the singularity continues to store energy until the moment of the Big Bang. Second one, the state of singularity that has existed since that moment has ceased. Finally, the universe is starting to expand. At the same time, singularity breaks down and the Big Bang occurs, and energy flows into space-time. At the same time, space-time also goes through three different situations in a similar way. As each particle is added to the singularity, the space also increases proportionally. Loss of stability of space. Finally, the space collapses down and penetrates into the singularity. One particle dissolves into the singularity and many other particles are approaching to the singularity. This is the scenery at the proper time of Big Bang. The Big Bang was never an explosion. The Big Bang is a breakdown of two equilibrium states of interaction. Space and the singularity are undergoing some changes at the same time. Both are simultaneous processes. This is an ongoing phenomenon. As the universe expands into the space-time, changes will also occur in the space-time, which is curved by the gravitational field. Here we can try to view the universe as two basic forms, energy and space-time. Energy, with the help of its own gravity, causes changes in space-time and expands into it. The universe is a mix of functional reactions between energy and space-time. Space-time may also be trying to survive the changes created by the energy in it. Anyhow, things happen from 0 to 10 raised to minus 43 seconds after the Big Bang are still unknown to us. But I will try to explain the situations of that period. 10 raised to minus 43 seconds is a shorter time than we can imagine. Think that if you wrote 43 zeros before 1, how small is this? In physics, such a short period of time we call it as Planck time. Hence, the period of the Big Bang to this time is called the Planck age. So we can assume that Big Bang happens in the 0th second. The new time which begins with the Big Bang will be added to the space-time. A new space-time will be created there. Space-time must have been created along with the Big Bang. Otherwise, there will be a time difference between space-time and the Big Bang. For example, suppose the time is added to the space after the Planck age, there will be a big difference between the timeline of the Big Bang and the timeline of the space-time. Right away with the Big Bang, the situation already existed, there is change. The energy stored as a singularity is released. A massive disorder in the curved space by the singularity will happen. The energy from the singularity will start to spread in the space-time. In this case, both systems will attempt to regain its lost equilibrium. The singularity of the Big Bang and the space destroyed by the Big Bang will prepare each other. Singularity is set to exert its energy to the space-time and space-time will prepare to accommodate it in. This kind of preparation must have been done during the Planck age. For that, the Big Bang singularity will be releasing a massive temperature. Space will absorb it. This will cause the temperature of the universe to decrease. As we know it today, the four fundamental forces that we know in the universe appear together during this period. The four fundamental interactions, namely strong interaction, weak interaction, gravitational interaction, and electromagnetic interactions, were separated after the Planck age. At the end of Planck age, gravitational interaction dissociates from the electronuclear interactions that has held it together. Gravity stays part of the energy and the other fundamental interaction become free. The inflation era then begins as a result of these preparations. We can realize that inflation has an important role in the expansion of the universe. Even in every action of our daily life, we can relate inflation or the Big Bang. After the Big Bang, we can see that there is an acceleration occurring in the expansion of the universe. The expansion of the universe in this state was an accelerating rate much faster than the speed of light. The inflationary epoch started at 10 raised to minus 36 seconds after the Big Bang. This may have lasted up to 10 raised to minus 32 seconds. During this period, space-time was joined together in the Planck era, began to penetrate into the distracted singularity with a massive velocity. At the same time, the energy released by the Big Bang began to penetrate rapidly into the shattered space-time. Both of these things happens at the same time. We can describe this as the interaction between energy and space. Here we see space-time and energy are acting as motivating forces to each other. Space inspires energy to penetrate in it. Similarly, energy invites space to penetrate in it. This is the reason for the tremendous acceleration of cosmic expansion during the inflation period.
All these situations are well described in my book, The Key to the Secrets of the Universe. You can see the evolution of the universe from the primordial stage until the destiny of the expansion of the universe in my book. There you can see a lot of new ideas on the expansion of the universe and about the gravitational interaction. I'm explaining there how the expansion of universe is undergoing to another Big Bang. You can find the link to the book in the description box.
In my opinion, physics is a true understanding of the characteristics of the universe. The nature around us provides all the answers to its phenomena if we look at it carefully. Inflation made me think a lot about Big Bang, the force created by the Big Bang and after effects of the Big Bang. It causes me to think deeply about what we do in our daily lives. I understand that we can keep track of inflation in every activities that applies force. In my logic, inflation is the effect which is created by an external force that is affecting an object or another force. We can view it in all actions. For example, if I am throwing a ball, at a velocity of 10 meters per second. We can ignore gravity for better explanation. It will continue its motion at the same velocity. It is obvious here that before I threw the ball, it was at an inertial stage. Its initial speed was 0. When I pull a force on the ball, it quickly reaches the velocity of 10 meters per second. We can observe inflation here. The time taken to reach real speed using uncontrollable acceleration. The force I applied to the object was capable of delivering a speed of 10 meters per second. Inflation is the initial acceleration of an inertial object when it suddenly moves. This fraction of a second we can say as the inflationary period of that force. In this period, the object will get acceleration at a very high speed at a very high rate according to the amount of applied force. When we talk about the Big Bang, we are talking always about the phenomena that occurred in the singularity. In my opinion, also space-time must have the same importance as singularity because singularity cannot exist without space-time. Singularity is a phenomenon with full of pure energy. Energy always needs some space to survive. That's why Albert Einstein included space-time as the fourth dimension. Three dimensions of energy with the fourth dimension of space and time together. Then we have to understand the changes that have been made in the space-time by the Big Bang. I would like to say these two processes together, many have come forward with the idea that there was no space or time before the Big Bang. I can never accept it. I believe that the universe exists only if space and energy coexist. Let us now take a short look at the event from the Big Bang to the expansion of the universe we see today. Each period of time needs to be well explained. I would like to go ahead and explain these periods in a very lucrative way. The reason is that many other great people have already explained this to us. We have read them all. However, for the sake of the completeness of this video, it may be presented again very simply. After then, we can discuss the structure of the universe. The Big Bang happens in the 0th second. Then the Planck era up to 10 raised to minus 43 seconds. We have already discussed the Planck age in detail. During this period, the basic forces such as gravity, strong, weak, and electromagnetic force are seen together as a single force. But by the end of Planck age, gravity was free from other fundamental forces. This starts the beginning of the grand unification era. By this time, the universe is starting to emit massive amount of temperature into the space. In addition, all three of these fundamental forces other than gravity appear together to be the electronuclear force. It lasted about 10 raised to minus 36 seconds. By the end of this period, the strong nuclear force had been liberated from other forces. This allows the formation of nuclei of small atoms. At the same time, nature of space-time must have been more flexible. The space-time that was part of the singularity was very much compressed. A flexible space-time is adapted to the new changes that have taken place in the universe. This allows the newly formed particles to move freely through the space-time. This allows the particles to easily distort their own space-time. Then came the beginning of the inflation era. It lasted about 10 raised to minus 32 seconds. As the space-time became more flexible, the high temperature created by the Big Bang can be distributed very quickly into the space-time. This will help to reduce the temperature of the universe. Henceforth, the space-time will play a major role in determining the structure of the universe according to the energy distribution of each period. Since then, the universe was moved to the electroweak era. This period, the weak nuclear force and the electromagnetic force are seen as single force. This period was conducive to the production of heavy but rapidly decaying bosons. It lasted about 10 raised to 12 seconds. Then it starts the quark era. It was from 10 raised to minus 12 seconds to the 10 raised to minus 6 seconds after the Big Bang. It is at this age that the four fundamental forces we see today begin to be distinguished from one another. That is, the rest, electromagnetic force and weak force, were separated from each other. It may be assumed that quarks and leptons were formed at this period. Then the period of up to 1 second is called the hadron age. During this period, the temperature of the universe was greatly reduced, allowing the quarks and leptons to bind together to be converted into hadrons. At the same time, all the opposite of these particles, antiparticles, is being created. Later in this process, they are undergoing through annihilation. During all this process, the energy was circulated in many forms into the space-time. The phenomenon known as neutrino decoupling is thought to have begun a second after the Big Bang. Today, the most abundant neutrinos after the photons in our visible universe began to travel freely during this time. Finding these neutrinos having very little energy is very difficult with our present technology. It is thought that billions of neutrinos move around us every second. During this time, the temperature of the universe was still high enough to create also electron-positron pairs together with neutrinos. After about 10 seconds, the temperature changes of the universe lead the electron-positron pairs to the point of annihilation. The period from 1 second to 10 seconds is also called the lepton age because there are still a small number of electrons left after this. The energy generated by the annihilation of electron-positron pairs causes the creation of photons. This period is therefore called the photon age. Within the first few minutes of this period, the process called nucleosynthesis takes place in the universe. From approximately 2 minutes to 20 minutes, the temperature of the universe helps for the formation of the nuclei. So, this time duration we call nucleosynthesis period. It was during the period that the initial forms of the atomic nuclei that we see today were formed. The first nuclei were formed by combining protons and neutrons that were able to take advantage of favorable conditions. At this stage, nuclei are formed similar to smaller elements such as hydrogen and helium. As the universe expanded, its temperature and density began to decrease. By this process, it took nearly 100,000 years to formulate the first molecule. We can call this period the invisible universe. During this time, the universe did not allow to pass light. Therefore, the universe was in a dark state. After 370,000 years, the universe has become transparent and allows light to pass on it. The changes occurring in this universe during this period are in favor of this. The temperature of the universe for about this period favors the formation of atoms. They create a situation to allow the freely rotating electrons to combine with the hydrogen and helium nuclei that already formed to create neutral atoms. The combination of electrons and nucleus will release the excess energy in the form of photons. With the formation of atoms, more space is created inside the universe, allowing the photons to travel freely. Thus, we see that the universe is gradually becoming transparent. So much so that going on, now we can say the basic fuel for the formation of the star has been created in the universe. However, we cannot say that stars immediately formed. There is a need for a favorable situation for the star to be born. Studies suggest that about 380 to 400 million years were taken for the first galaxies to born. This is how we explain the evolution of the universe in general. The cosmic evolutionary structure, in my mind, involves in the reaction of space according to the changes in matter.